Hi, Audrey. Hi, Gabby. Good morning. You did. Not sure you're buying gas just yet, but yeah, gas prices are pretty low. Of course, you shouldn't be going anywhere, so you should be getting like 3 days to the gallon here. Alright, I think I'm set up for this. Alright, today we're going to work on graphing some quadratics. So what I would like you to do is find a piece of paper and a pencil and graph a bunch with me today. Just follow along in your notebook or on graph paper the best you can. There is nothing to turn into me today because I don't want a picture of a graph that, well, let's face it, if you handwrote it, I barely can read it anyways. But I do want you to practice graphing these. They get a little cumbersome just because there's a lot of steps to it. There's a lot of information you got to pull out here, and a lot of these graphs can do some strange things. So we're going to look at graphing them and how we graph them today, and we're going to do that by just graphing a whole bunch of them. We're going to walk through them, and we're just going to rationalize why things are making sense. But yeah, I'm going to do a bunch of examples on graphing today, and there's going to be steps. I'm sorry, Audrey. I woke up early and had to do some yard work before the rain started because we're rebuilding a patio. Um, so that's what I've been doing this morning, and that's why I'm running a little late here, but we're doing all right. So let's look at our first function here. Our first function, and remember, quadratics are going to be in the form of f of x equals ax squared plus bx plus c. And here we have an a value, a b value, and a c value. So we have one of each here, unlike yesterday where we only dealt with a values. And we're going to graph this. Now we need all this information in order to graph it and what we looked at yesterday. So first step for graphing this is to just take a step back and look at what you know. So first off, we know that a equals -3. We know that b equals 6, and we know that c equals 5. And again, this is a positive and this is a positive. I can write the positive sides to remind us, but normally if they're not there, it's there. So a being negative, this tells us that our graph opens down. So it's going to look like a parabola that looks like this. It's going to go that way. Our vertex will be up here, and it's going to be a max because it's going to be the highest point. So just because this is a negative, I know it looks like that. Because this is a 3, which is a pretty large number compared to 1, 1 would be kind of just average width, I'd guess. But because this is a 3, it is going to look a bit steeper than a lot of them. So just keep in mind that. So it's going to open downward like that. And that's just based off of what we did yesterday and our patterns that we saw there. So we know it's going to open downward, we know it's going to have a max as a vertex. Step one, after you figure out, after just looking at it, I got that information just by looking at it. So taking a step back, look at what it is, and then I'm going to come back to it and make sure my graph is doing this. Make sure it's making sense there. So step one is going to find your line of symmetry. So where is this symmetrical along? So we're going to find the line of symmetry. And a line of symmetry is actually based off of the ratio of B to A. So line of symmetry is going to deal with these two. That was a horrible bracket. But it's going to deal with A and B. And it actually follows this. One, it's going to be a vertical line, so I want to know where it's going to cross the x-axis, and then I'm just going to go vertical from there. So x is going to be equal to negative b over 2a. And this is going to be the same formula you use to find your line of symmetry for any of these. So in this case, negative b is going to be negative 6, because b is 6, so negative b would be negative 6, divided by 2 times a. A is a negative 3, which is going to equal negative 6. I should close that parenthesis, over negative 6, which is going to equal 1. So here our symmetry is at x equals 1. So what I'm going to do is I'm actually going to use my symmetry tool here, which you probably don't have. But anyways, x equals 1 is right here. So it's going to follow this line right there. This here is our line of symmetry. Which also means, if this is your line of symmetry, step 2 says to find your vertex. We know the vertex has to be on that line of symmetry. So if the vertex is on this line of symmetry, we know that the x-coordinate to our vertex has to be 1, because every x-coordinate on this line is 1. So if we know the x-coordinate, we can find the y-coordinate easily by just plugging in 1. By plugging in. So I'm going to take my original equation here. F of x equals negative 3, and for x I'm going to plug in 1 because that's my x-coordinate. Keep in mind I have a couple x's to plug in for. And then I solve for my y-coordinate, and I'll get my y-coordinate pretty easily that way. So 1 squared is 1. 1 times negative 3 gives me negative 3. 6 times 1 is 6. And then 5. Negative 3 plus 6 gives me positive 3. Positive 3 plus 5 gives me 8. So my y-coordinate is 8. Which means my vertex is at 1, 8. So I know here should be my max. Of course, I have my symmetry tool up, so I wrote all that over here too, didn't I? So I know my vertex has to be here. Step 3. I want to find my y-intercept. So what am I going to do? I'm running out of room here, but anyways. Find y-intercept. And if you recall from linear equations, this is where your x value equals 0. So what is this point where x equals 0? So you go up here and you plug in 0 for x, and every time you do that, hey, 0 times, well, I can do it to this one here, right? Looking at this right here, if I plug in 0 for x, what does y equal? 0 squared is 0, 0 times a is 0, 0 times b is 0, 0 plus 0 is 0. You see how these two terms cancel out, and you're just left with c? So your y-intercept is actually going to equal your c value, and here our c value is 5. So our y-intercept is 0, 5. So I can go ahead and plug that in, which is right here. Let's move that piece down. Right, 0, 5, which is right here. And you'll note, because this is a line of symmetry, that's also going to give you this point over here because it has to be symmetrical. And it has to be folded along this line. So you actually know 2 points because of this. After that, you technically have enough to graph this, but to make it actually look nice and accurate, you're going to find another point just to make your graph look nice and readable. And again, if it's not readable, it's really not worth doing. But you are going to have to find actually 2 more points, but you know the reflection is going to work. So you're really just going to find 1 more point. So with that, you're just going to pick a random, number 4 is going to be find 2 more points. And you're just going to pick random xy values, well, x values to plug in to your xy table here. Pick a value, you only need 1. Of course, my symmetry is going on. You only need 1 point because you're going to reflect it, and you'll get the other one. So you're technically finding 2 here. But let's plug in, I don't know, 2 and see what we get. So coming up to here, we get 2 squared is 4. 4 times negative 3 gives us negative 12, plus 2 times 6 gives us a positive 12, and plus a 5 gives us just a plain old 5, because these will cancel. Gives you a 5. So 2 and 5 is a point, which we already found. That was our reflection point, so that's good. I guess we need to do another one. I should have saw that beforehand. Let's do, I guess, 3. If I plug in 3, 3 squared is 9. 9 times negative 3 is negative 27, plus positive 18, plus 5. 18 plus 5 gives you 23. So that gives you a negative 4. I'm just double checking that. And negative 4 looks good. So then at 3 we're at negative 4, so we're all the way down here. And again, you're going to get the symmetry to it. Of course, my line of symmetry moved. I got rid of it. You're about there. And then you can go ahead and connect your dots in a nice curve the best you can. However, again, I'm not the greatest with the stylus. And there is one graph. It does take a few, well, step 5 is reflect the point to get the 5th one, right? 5, I think I had reflect point. And then step 6, connect in a curve. Best you can. And that's how you graph them. Once you have it graphed, you know all the points to it. But that is one way to do it. Your x-intercepts might exist and might not, which we'll talk about in future lessons. But for this purpose here, that's how we're graphing them for now. There are other ways, but this here is probably the most systematic and straightforward of them. Keeping in mind, this formula here is important for finding your line of symmetry and knowing your A, B's, and C's and how that works with your vertex is probably the newest stuff. Other than that, it's just kind of like plugging things in and finding the answer. So we're going to do a few more of these today. Again, I'm not collecting anything, but I would like you to follow along. I am going to do it out of the book. So do I have layers? Everything's in the same layer, isn't it? So I am going to follow along in the book if you want to follow along with the problems. I am looking at page 520, 11 through 14 right now, and 23 through 31 if we need more practice or if we have more time. So I'm going to look at number 11 out of your book on page 520, and that is saying, I don't know what it's saying, f of x equals x squared plus 4x plus 3. So looking right away, we need to find our line of symmetry, which again is going to follow x equals negative b over 2a. In this case, we have a equals 1 because there's no value there, b equals 4, and c equals 3. So just keeping everything straight, I have negative 4 over 2 times a, which is 1, and this is going to give me negative 2. 2 times 1 is 2. Negative 4 divided by 2 gives you negative 2. So we know our line of symmetry is at negative 2. So again, if we were to put that in, I'm looking over here at negative 2. That also means our vertex is going to have the x value of negative 2 and a y value of we don't know yet. We're going to plug in to find out. So f of x equals negative 2 squared plus 4 times negative 2 plus 3. Negative 2 squared gives you positive 4. Watch your negatives there. That negative sign is being taken to it, so that is negative 2 times negative 2, which is a positive 4. Plus negative 2 times 4 gives you a negative 8 plus a 3. That gives you, what is that, positive 4? No. What is that? Positive 1. Negative 1. Yeah, 4 plus 3 is 7. Negative 8 minus, or negative 8 plus 7 gives you negative 1. Yeah, so that's negative 1. So we know our vertex is on our line of symmetry and at negative 1 on the y. So we know our vertex is here. Keeping in mind, A is positive, so we know this is opening like that, and we have a min, just so we are familiar with it. And that's making sense right now, even though we just have a dot. Next, we want to find our y-intercept, which is going to be equal to c, which in this case is 3. So our y-intercept is going to be 0, 3. Again, we know it's going to be reflected over that line, so that goes over here. Of course, I think, yeah, it's in the same layer. I should not have done that. It's right there. Gets reflected over. Then we need an additional point. So another point. We're going to do an XY table for it. We do not want to use -4 as x because we've already got that point. And we don't want to use 0 as x because we already got that point. So I'm going to go ahead and just pick 1 because 1 is pretty easy to work with. If I throw in 1 here, I get 1 squared plus 4 times 1 plus 3. 1 squared is 1. 4 times 1 is 4. Plus 3 is 3, and that equals 8. So y is 8. So at 1, we're up at 8. And again, it's going to be reflected over that line of symmetry. So at 1, 2, 3, 1, 2, 3, this point here will also be on our graph. And you just make a nice curve. Why did it not like that? Yeah. And there you go, you got another one graphed. So, any questions so far? I mean, it's just a lot of steps. They're not hard steps, it's just a lot of them. And just keep in mind on what we're doing. So, it's going to just take some practice, so let's keep practicing. Let's look at do this. Let's put it in a different layer. Is it in a different layer? Yeah. Let's just set this up again. There's our graph. Let's put it in layer 1. I wanted. We are on page, is it 520? We're doing number 12 now. So number 12 says y equals 2x squared minus 6x. Let's see if I set this up right. Yeah, that looks better. Okay, so in here again, just to keep yourself a little organized, we have an a value, a b value, and a c value. A value equals 2. B value equals -6. And a c value actually equals 0 here. We don't have a c value. Well, we do have a c value, it's just 0. We don't have, because when you add 0, it doesn't change anything. So just keeping that straight. Step 1 is line of symmetry, which again, x equals -b over 2a. And in that case, -b is a positive 6 over 2a, which gives us, I'm sorry, a is 2 as well, which gives us 6 over 4, which gives us 6 divided by 4 is, how do I want to write this? Yeah, I'll do it as a mixed number. Alright, 1.5. Then 1 as a mixed number? Yeah, I'm going to leave it as a mixed number. 1.5 is probably easier than 3 over 2. So, I mean, you could graph it as 3 over 2 as well. Might help. I don't know. 1.5 is probably what you're more familiar with. So line of symmetry is going to be at 1.5, which is about right. A little more. Close enough. Right there. So our vertex is going to be where x equals 1.5 and y is going to equal you might like the fraction better than the decimal or mixed number here. That's why I was debating it, but you can use a calculator if you get confused on operations. But 1.5 times 1.5 gives you 2.25, and times 2 we're getting 4.5. So this is 4.5 minus 6 times 1.5 gives us 9. 4.5 minus 9 gives us a negative 4.5. That's half of it, isn't it? Yeah, it's going to give us a negative 4.5. And at negative 4.5. Keeping in mind, we have a positive A, so it's opening upwards, and we have a min. So negative, or positive that, negative 4.5 is like right here. Next we find y-intercept, which is equal to c, which is 0. So this is at 0, 0. Right there, we have its partner on the opposite side of our line of symmetry, and let's find another point. We can do 1. 1's not chosen yet. We don't have anything there, so we can plug in 1, see what we get. Another point, xy table, let's plug in 1. 1 squared is 1, 1 times 2 is 2, plus, minus 6. 1 is going to give us a negative 4. So 1 is here, negative 4 is here. Keep in mind our symmetry goes over. Once that's settled, you just draw your curve. And it's graphed. So you have your vertex, and line of symmetry, and so on. Again, just going to take some practice. So let's just move on to the next one. Let's look at 13. Equals negative x squared plus 4x minus 4. Just to keep yourself organized, you know your a value here is negative 1, you know your b value is 4, and we know your c value is negative 4. Coming right out of our equation, just things we know. Due to the fact that a is negative 1, we know this is opening downwards like that, and our vertex is going to be up here, and we have a max. So you should have that kind of in your head. We're going to find our line of symmetry, which again, x is going to equal negative b over 2 times a. In this case, b is 4, so negative 4 over 2 times negative 1. And you're going to get negative 4 over, and then 2 times negative 1 gives you negative 2, and this is just going to equal positive 2. So you know your line of symmetry is at x equals 2. So go ahead and take that into consideration. It's right there. Vertex. We know x is 2 from our line of symmetry. And when we plug in 2 for this, we get y equals -2 squared. Now keeping in mind that negative is outside the 2. Plus 4 times 2 minus 4. This becomes -4 plus 8 minus 4. And you get 0. So our vertex is right here at 2, 0. And with that, we can find our y-intercept. Actually, we don't need that. We just know what it is because y-intercept equals c, and c in this case is at -4, so our y-intercept is 0, -4. Which, again, you're going to get the symmetry with it. So 0, -4 is here. So you get this point over here as well. And again, they're symmetrical. That's how I know it. Then we're going to find another point. Use your XY table. Look at your graph so you know what you don't have. Again, we don't have a 1. We don't have a 3. Don't use 4 because you already know the answer. Don't use 0 because you already know the answer. Don't use 2 because you already know the answer. So when x equals 1, let's plug that in. We get, again, this negative sign is not part of the x coordinate. It is part of the function. So it is outside the parenthesis. And this gives you -1 plus 4 minus 4. So it's just going to be -1. So 1, -1 is your point. Again, watch your line of symmetry. 1, -1 is here, so your line of symmetry tells you to go there, which means your graph looks like this down there. It's the best you can. Alright, we're going to do one more. It would be a good idea for you to practice doing some more, which is why I gave you, what is it, 23 through 31 if you want to practice. I am not collecting it because it's a graph and I'm not sure the best way to collect it. Sure, you could handwrite them and take a picture, but then half of your pictures I can't even read. And on top of that, half of you don't make very legible graphs either. Your handwriting's just not there yet. But I will just trust that, hey, you're practicing graphing them. That is your assignment for today, is to practice graphing them. Do you have to do all of them? No, it takes a minute to do these. So, I mean, just be practicing graphing some. We're going to probably look at graphing some tomorrow as well. Just because I don't know if I want to start the next thing and then go on break and reteach it, which is finding and estimating square roots. So I think I'll just hold off on that. So I think we'll spend tomorrow graphing more of them. So give them a shot tonight, and then we can check them tomorrow in class. But let's do one more today. Let's look at number 14. And then I'll let you go and practice on your own. And we'll do some more practice tomorrow. So number 14, y equals 2x squared plus 3x plus 1. Over here we have an A, a B, and a C. Just keeping ourselves organized on what we're doing here. We got a 2, we got a 3, and we got a 1. Because this is positive, we know it is opening like that, and we know it has a min. So over here, let's find our line of symmetry. However you spell that. We know that line of symmetry goes by the formula -b over 2a. So b is negative 3 over 2 times a, which is 2. So your line of symmetry is at an ugly place of negative 3/4. Again, you might like the decimal as opposed to the fraction. I kind of tend to like fractions, but you might like that as a decimal, so it's like negative 0.75 if you want to do it that way. But let's stick this here. Negative 3/4 is about right there. Not the greatest line of symmetry, but it is there. You are more than welcome to make your scale to go in fourths as well if you wanted to. I'm just not going to find a scale that does that for the computer, but you could say, hey, this is 1/4, this is 2/4, this is 3/4, this is 4/4, this is 5/4, this is 6/4, this is 7/4. You could just sit there and say, hey, everything is in fourths. That is one solution to make that a little nicer for you, but we'll deal with it. I don't want that on. Our vertex, our x value is negative 3/4, which means our y value is going to be whatever that is in here. So 2 times negative 3/4 squared plus 3 times negative 3/4 plus 1. So that's fun to do, isn't it? Again, if you like the decimal, go ahead and use the decimal. I'm doing something wrong here. These numbers are gross. 2x squared plus 3, 1. Everything's looking right. I'm just going to double check my math on that. Yeah, it seems to be what I'm getting. So I am kind of in here. Again, if you wanted to, you could have just made all these like a fourth, a fourth, a fourth, and it would make graphing this a lot easier. But we have negative 3/4 and negative 1/8. So you're about right there as your vertex. Y-intercept is 1. So you also know the symmetry of that. It's going to be roughly there. Best you can. Let's pick another point. We'll say is 1. If I plug in 1 to that, what do I get? 1 squared times 2 is 2, plus 3 plus 1 gives you 6. 1 and 6. Again, symmetry of that puts that over there. And connect the dots the best you can. And that there is our graph. With that, pick a couple from page, what is it? I guess that's 521, 23 through 31. Pick a couple of those to try on your own tonight. And we'll look at some more of this tomorrow. Again, not too difficult to do, just kind of a lot of steps to go through. So practice, practice, practice is how it's going to work. And with that, I'm going to end it. If you have questions about things, please email me. That includes science. I think most of science is unlocked. I don't think I have your assignment sheet up yet. But you know you can do the notes and stuff like that. I'm trying on the assignments here. I'm still thinking of things because I had things that were kind of more partner based and in-class kind of assignments for what was going on. So I'm still trying to adjust that, but I'll keep you posted on when that's released. You can work on key terms, notes, and section assessments as always. If you have any other questions, send me an email. And I'm saying goodbye. It's past 10 o'clock, so I used a lot of your time today. So talk to you later. Bye.